Hi, welcome back to another episode of Real World Serverless, a podcast where I speak with real world practitioners and get their stories from the trenches. Today, I'm really excited to welcome Ben Cahill from iRobot onto the show. Hi, Ben. Good to see you again.
Hi, happy to be here.
So, you and iRobot are almost, I like to say, the poster child for Lambda. You guys been doing really hardcore stuff on serverless and Lambda for quite a long while now, and doing some really high throughput as well. So maybe let's get started by just talking about what you've been doing at iRobot and how did iRobot go down this road of serverless.
Yeah, so I joined iRobot in 2015, um, while we were in the process of launching our first connected Roomba, the Roomba 980. And so while iRobot's been around since 1990, a scaled out connected robot was not something we had done before. We'd done networked robots on a smaller scale. Our Roomba business, obviously in 2015, was already big, selling millions of robots a year. And so we didn't have a background in cloud computing. And I didn't really have a background in cloud computing. I was coming from grad school where I'd worked on cloud robotics, where, sort of what can robotics do while leveraging the cloud. But as a grad student, you're not necessarily using giant fleets of robots or things. You're doing, sort of more theoretical proof of concept stuff. And so iRobot had chosen early in the project for the connected Roomba a full solution IoT cloud provider. And the purpose of that was that it was turnkey. We didn't actually have to build it. It was a platform. It handled authentication. It handled delivery of firmware updates. It had a scripting platform on top, all of these things. But they'd really built it for industrial IoT, which allows, there's a lot more data, there's a lot fewer devices, and your control often doesn't need to be real time, where all of those are kind of flipped in consumer IoT. And so even before launch, we were aware that that platform wasn't going to scale to Roomba volumes. One of my first tasks at iRobot was to build some scale testing to knock the system over to prove to them that they weren't going to scale to the volumes that they had claimed, which was fun. I got to set some things on fire. So we knew even before launch that we wanted to shift off of them. And two things were involved in there. You want your IoT connectivity layer, which deals with authentication and traffic from the robots. And then we wanted to own the application that was behind that handled all of the business logic and all the things that went into that. And we wanted that because by 2015, we had realized that being a part of the smart home was an integral part of our strategy. So we wanted to control more of our destiny in the cloud application there. And so we ended up selecting AWS IoT Core as our IoT connectivity layer. And then we knew we wanted to build an application behind that on AWS. And again, we had people at iRobot who had previously built, scalable systems, but not a lot, and not at iRobot. And so, we sort of looked at the selection of services on AWS. IoT Core is, of course, completely serverless. There are no knobs to tune there. And Lambda was new, API Gateway was new, DynamoDB had been around for a while. S3, SQS, SNS, all of these pieces were there, and none of them required running servers. And we said, well, we think we can probably build this without actually having to learn that step to build auto-scaling server-based systems. And then we don't have to go through all of that learning as it scales up very rapidly to the size of the Roomba fleet. And so we invested in that, and it's been very successful. And we still don't have any containers or VMs handling transactional traffic from our connected robots and apps. There's certainly some, container-based jobs, AWS Batch, things like that, more on the analytics side. But in the OLTP side of our application, it's still fully serverless.
So I remember, Lambda and API Gateway in those early days, 2015. It was a very different, I guess, offering and capabilities compared to what we have today.
Yes.
So as an early adopter, What were some of the biggest challenges and the problems that you guys ran into in those early days?
Well, I think none of us in the serverless community really had any idea what we were doing back in 2015. This was back when the serverless framework was brand new and still called JAWS. And when we looked at all the things that we needed to do, we didn't see any deployment framework that fully met our needs. And so we decided to roll our own, which is always a last resort when you're serverless. You want to buy something rather than build something if you possibly can, but it was the right decision at the time. And so that locked us into sort of tooling built around a specific architecture that we still have. Um, and so, a significant double-digit percentage of our lines of code when we shipped our application at first was in the tooling that we had built. That's not really true anymore, but it gives an idea of the amount of work going into both just building the tooling, but also sort of predicting and establishing best practices. And I think a lot of the decisions we made early on there were not ones we would make again if we were building brand new, and isn't really what we're making when we're building new systems outside of that.
Yeah, I remember using JAWS, at least trying to use JAWS in those back in those days. It just didn't work the first time I tried it. It just didn't work out of the box. So I ended up having to build some kind of couple together a bunch of different scripts and the CloudFormation to get it to work and have some kind of deployment framework myself as well. Thankfully, nowadays the tooling has got so much better. Nowadays, probably have a different option, different problem where we have too many different options, and again, not clear, I guess, consensus in the community on how to choose which one.
Yes.
So you guys been so I guess fast forward a few years. Nowadays, you guys are running Lambda at a pretty massive scale. Are you able to talk about any of the sort of numbers or peak throughput? What sort of peak concurrency you're running at?
Yeah, I mean, we talk, the last time I checked, which was like a year ago, our traffic is spiky. Our Roombas are scheduled. And so 10 a.m. Eastern time every day there's a massive inrush of traffic as for whatever reason, the highest volume of scheduled robots during a 24-hour period. It's interesting to see because that's people on the East Coast who are scheduling it at 10 a.m., but people in Europe who are scheduling it much later. Um, and that just happens to be the confluence. And then, our weekends are busier than our weekdays. It's very spiky, but we don't really look at the spikes for volume of traffic. I think if you average it out across everything, across an entire week, it's in the hundreds of requests per second because our robots, and that's across all the lambdas kind of thing that we estimate for. It's yeah, and that's because robots are they're not very chatty when they're outside of a mission because there's not much going on with them. They're sitting on the dock waiting for something to happen, reporting that they're still there. During those times, those robots are not very chatty. And then there's these big inrushes, big spikes in volume when robots are starting scheduled missions.
That's actually quite funny that there's some correlation between everyone who owns an iRobot, a Roomba, that all kind of, I guess there's like a particular time in the day when everyone seems to be running their iRobot robots in their homes at the same time.
In the app, when you schedule it, it lets you schedule for like the hour, the half hour, or whatever. So we're guiding people into those schedules.
Right, I see. Okay, so that makes sense, and also I guess it makes sense for them to run probably more often on certain days of the week as well. Um, so in that case, when you have a sudden spike in traffic, do you ever run into any of the sort of service limits that Lambda has in terms of the sort of initial burst capacity limit in your region, or is that just not a problem because robots will just retry if they ever get throttled?
Yeah, I mean, there's a lot of traffic that doesn't completely exit uh, the um, like a lot of those. So the request volume from our lambdas is lower than the request volume, like the message volume into AWS IoT. because basically everywhere where messages are coming in to AWS IoT, they're ending up batched into a Lambda function. So for example, we have an Elasticsearch cluster that indexes the device shadows in AWS IoT. And there's a big Kinesis stream that listens to the very large volume of requests that go into IoT through the shadow. And then, of course, we're pulling out large batches of requests out of that Kinesis stream. So I think there's few places where the Lambdas really need to scale up very quickly because of especially Kinesis, which allows it to back up a little bit, but also the batching in general. And then for AWS IoT, they have a pretty good understanding of our traffic. And so we don't see a lot of throttles off of there. For us, a big event is Christmas morning. All the people who have bought robots from Black Friday until Christmas open them in about a 4-hour window on Christmas morning. And so there's this giant inrush of traffic there, but we work with our account team and the AWS IoT team to let them know this is what our expected volumes are, and so that can all be pre-warmed for us. And so I think, with Lambda, a lot of that now is self-service with provision capacity, and provision capacity, right? Not the reserve concurrency. Yeah. And so you can self-service that for Lambda if you know what your traffic patterns look like, which is something that we do. But most of that happens within AWS IoT for us.
Yeah, it's funny that moment there when even an expert like yourself have to double check yourself. Am I talking about reserve concurrency or provision concurrency? The naming is just so confused.
Well, the naming is weird, right? Reserved is like I'm reserving concurrency. Is concurrency going to be there? No, it's only if I've provisioned it will it be there.
Yeah, oh my god, it's the naming just gets me so twisted. Are you running everything in one single region, or do you also have a multi-region setup as well?
Yeah, we're mostly in US East 1. And that's primarily because most of the things that our users are doing are not seeing the latency. They're talking, like if you're at home on the same Wi-Fi network as your robot, the app talks directly to it, and therefore you don't really see latency there. So we're not as latency sensitive as other applications might be. And so we've chosen a single region strategy. Same for failover, is that the current functionality that we have isn't primarily, it's not mission critical to our users' lives yet. And the robot will still clean. If you set a schedule, the robot will clean on that schedule, even if the cloud is out, even if your Wi-Fi is out, and you can always push the clean button. Same with that direct connection that you can make. And so today, those failover scenarios and those latency scenarios aren't high enough priority in terms of our customer needs to make the complexity worth it. But as our feature set grows, as our connections in the smart home grow, and more of the value that we see of having a connected robot in the home materializes, I think some of those things may change.
So you mentioned earlier about the whole pre-warming for IoT Core itself. I remember doing the same thing with load balancers in the past, where when you have a new product launch, you know the traffic is going to be very spiky. Does the IoT Core itself, I guess, it also just auto scales, right? It's just that you've got a spike coming in. So
Yeah.
okay, that's why you need to ask them to pre-warm.
Well, and it's good. I mean, this is not something, Christmas we need to talk with them about. We're getting a very large influx of robots in a relatively short amount of time, um, and we want all of that to go well. And so we talk with them about that. But it's not, it's not something that we have to normally talk about them with for other kinds of spikes. Prime Day, for example, that just works. So they scale up and they're pretty good about accepting messages, and even if the delivery, needs some scale up before that happens.
Have you ever run into issues around the delivery in terms of duplicated messages being delivered from IoT to Kinesis? There's some problem that I've experienced with a few of these async event sources that push messages to Kinesis that when you pick them up from Lambda, sometimes you just get duplicates. I think with CloudWatch, that's quite a common one I see that you end up having to write some code around that. What about with IoT Core? Is that something that you guys have to deal with?
We design all of the messages that come from the robot to be idempotent. So they're all QoS 0. So originally with IoT, you paid for the ACK message that was sent back down to the robot in QoS 1. And when you have lots of robots and lots of traffic, that cost can add up. So all the traffic currently from the robots is QoS 0. And so duplicate messages can end up being sent. So everything we sort of design around being idempotent. Updates to Shadow that we index, for example, that's just fine for there to be duplicates. Records that come from, at the end of a cleaning mission, a robot uploads a little report of it that goes through IoT into a DynamoDB table. That ID is stable, so even if that gets updated later, that's fine.
Okay, that's pretty cool. So one of the things that I get asked a lot is just what event source I should use as a queue. There's so many different options. I guess given the sort of volume of messages you're dealing with, Kinesis must have worked out a lot cheaper than if you had used, say, EventBridge or SQS or SNS, which at volume, those services are so much more expensive compared to Kinesis.
It's something that we haven't had to look too much at yet. We chose Kinesis because the SQS integration, didn't exist for a very long time. We built a custom resource to do the integration, but we only used it on lower volume things. All the very high volume stuff goes through Kinesis. Part of the value of Kinesis is that it's a buffer, right? That if whatever's downstream is broken, your Kinesis stream will just back up. And this happens for us because that Elasticsearch cluster that I mentioned, that falls over occasionally, which for us is fine because there's no time critical things that query that cluster. So it's totally fine, and it fills back up with current shadow data all the time. So once you just stand up the cluster again, it gets filled pretty quickly. So our requirements around it aren't very strong. And so when that happens, the Lambda that fills that Elasticsearch just starts failing, and the Kinesis team just starts backing up. And then once the cluster is back up, the Lambda starts working and the Kinesis stream empties out. And you don't have to do anything. And that's not true with SQS today, right? With SQS, you're reading from it, and all of a sudden your downstream goes down, and your DLQ is just going to fill up with all the records as they fail enough times. And then you got to redrive all those messages, or you got to figure out, oh, something's failing. I got to turn off my Lambda, set the concurrency to 0, and wait for it to come back. And to test it's coming back, I got to turn that concurrency back up a little bit. So you got to do a bunch of things that are a lot of work and undifferentiated heavy lifting. And this is one of the reasons that Lambda, or AWS in general, needs to build sort of a circuit breaking service, right? Your ability to do these things requires a very stateful process. You got to maintain, there's some downstream health that I'm paying attention to, and I'm marking it. It's not just if one call fails, it's if several calls fails, in a given timeline. And sure, I could make a CloudWatch alarm for it and do all these things, but then I need to store the state of that somewhere, and then I need to use that state to drive a change in Lambda concurrency, and then I need to occasionally check on it to see if it's better. Because if I keep the concurrency at 0, I'll never get any more information about whether the downstream is healthy again. And so that feels, it's something that a customer can build, but is very much undifferentiated heavy lifting. And I think it's sorely missing. It's something that, is built into container systems. Istio and Envoy have features that help with this. And in the serverless world, we're just completely without it.
Yeah, I couldn't agree more with that. Something that we definitely are sorely missing. I think we had that conversation with Paul Johnston and the Jeremy Daly as well. Literally, we had about 4 or 5 different ways of implementing basically the same thing. Whereas it'd be so much better if AWS just provided. I think that brings us nicely to actually maybe before we move on to what I want to talk about in terms of some of the missing features in the serverless offering from AWS right now. One last thing I want to touch on is with Kinesis, one of the missing pieces there is the auto scaling, which I've had to build a couple of times myself. Are you guys doing anything with auto scaling, or do you just say, no, screw this, we're just going to run at a certain number of shards and just be done with that?
Yeah, I mean, our traffic is pretty predictable. And so we don't, the resharding happens fairly rarely. In fact, I think one Christmas, the literal only operations work that we need to do was upshard one of our Kinesis streams. And so if that process had been automated, it only happens every couple of months. But if it had been automated, that Christmas Day operations for that massive influx of traffic, which is like 20x-ish our normal daily traffic, would have been completely hands-off keyboard. Now, auto-scaling for Kinesis is great, but that it implies that I still have to manage shards, right? And so what I really want is just that I can shove data into Kinesis, and I still have the same guarantee, which is for any partition key, the messages are ordered. But today you have a notion of, multiple partition keys are on the same shard and they'll all be ordered relative to each other. But I'm fine giving that up in exchange for I don't have to manage shards. And that's, I think, the bigger serverless dream.
Absolutely. If you can have the same pricing model and scaling model that Firehose gives you with just normal Kinesis data streams, that would be amazing.
Yeah.
And so I guess that brings us back onto that question I was going to ask you just now is what do you think are some of the most pressing, missing features that we have with the serverless offerings on AWS right now? You touch on the lack of some kind of a auto-scaled Kinesis, but also the lack of circuit breakers. Anything else that comes to mind?
So we talk a lot about Lambda and services like that for serverless, but serverless is really more about your infrastructure graph. Like the amount of code that I need to write for a given application should trend downwards over time until it's literally just my business logic. And even that, when I think about lambdas that I write today, where all I'm doing is gluing together AWS services, and then I look at systems manager automation documents where I can, in a declarative way, say, just make this API call and then make this other API call. Being able to define the transformations that I need to do in a Lambda function without actually writing any code that has the possibility of going stale, like when all I'm doing is AWS API calls and JSON transformations. Writing code for that is kind of an overhead, especially operationally. Now it's something else I need to watch. So I'm always on the lookout for how can I write less code? How can I do things more declaratively? But I also think, as we write less code, then we're bringing in more services to do things. And while we're trying to make that easy and such, we don't have good tools for understanding those things as applications fully made concrete in the cloud. I think the AWS CDK is doing work on that front, but their take on it is that it's okay for it to be client side, for the information about what an application is to get sort of lossily flattened out into a set of cloud resources that then get deployed. And I don't think that lossy step is acceptable. I think the concepts that the developer is expressing in terms of what they want and how they want to represent their applications need to be fully represented cloud side, so that then when they go and there's something wrong, they can fully trace their understanding of the system through like the AWS console, rather than needing some client side tooling that may be specific to a development environment. For example, if someone says, oh, something's going wrong, and you know, the person who designed it was on vacation, another person shouldn't have to like clone their repo to just get started with trying to fix it. And so that's where I think client-side solutions are not the answer. And so I want to see more of that. And I think people like Stackery are making progress on that front. On the client side, though, during development, I think we need better tools, better integrated tools from AWS. So we have the SAM CLI, we have the ECS CLI, we have the CloudFormation CLI for doing resource provider development now, and the number of those command lines is only going to explode, and they're all doing very similar things, and it's hard to glue them together. We have a task right now where we have a step function, and most of it's dealing with lambdas, so we're using SAM, and then we ran into something where it's like, well, this job is going to run longer than 15 minutes. It's collecting, and it's going to need a bunch of either memory or disk space, and so we can't run it in Lambda. And so an ECS task is the thing that makes the most sense. It's low rate, so it's not it's not difficult to handle. But it's just hard to be like, oh, I'm working in SAM. Now I need to add an ECS task. How do I even develop for that? I can't package up that Docker file and get it into ECR and stitch that ECR image into my template in the way that SAM does for zipping files for Lambda. And that makes us want to like resort to using a code build task, which would work, but isn't the right way to go about it, because it's much easier to just define that inside your template and not deal with all those complexities. And so having a better unified sort of AWS dev command line with like plugins for the services that you might be using that enabled you to set these things up, I think might be a better way forward, as people need to stitch more of these different ecosystems together. Yeah, so I think those are some of my wish lists.
Okay, that's a a pretty comprehensive list.
Oh, I have many more, but I think that covers some of the big items.
There's a lot to unpack there, but I want to maybe go back to the first one you mentioned around the whole basically writing your workflow without writing custom code. I know you guys use step functions quite heavily as well. I'm a big fan of step functions,
Oh yeah.
even though I guess the way you kind of do it is maybe not as nice as say something like Node-RED, for example, from IBM. Where you have this really great visual tool where you can design your workflow, and then you can also just switch out to the sort of YAML or JSON editor view. Can you maybe talk about some of the use cases you have with step functions right now, and how do you feel about sort of where we're going with step functions, and what's currently missing there?
Yeah, I mean, we love step functions. We use it for everything we can. So any automation process that isn't just a single Lambda is pretty much a step function. And we like that we do long running jobs that are iterative using step functions and Lambda. So, just recently we had a task where today there's an SQSQ and a client side script that churns over a large list of items and puts those elements in an SQSQ for processing. And there's a recent job where that took the developer, it had to run for like an hour on their laptop. And so we're going to move that to be, well, you just put that input file in S3, and then we'll fire off a step function based on it that will, keep its place in the file. The file is relatively small. There's just some like parsing and API call work that needs to be done for every line. And so we'll do that in the Lambda until it runs out of time, and then we'll just loop back around. And now if it was super easy to set up that ECS task or a code build task, we could do it that way. But in general, Lambda for this ends up being easier to manage as a development experience. And so then we just have a little loop that keeps a pointer to how far through the file it got through. And so we use step functions like that in all sorts of ways. The map state opened up a lot for us. We used to have a lot of parallel states that were pretty cumbersome to deal with, to the point where we're thinking about building a CloudFormation macro to help stamp out large parallel states based on a single branch. But then the map state came around and we didn't have to do that, so that was great. But yeah, designing them is hard. Manipulating the state object through all the JSON path expressions can be a pain. They're still missing. We're big into RoboMaker now, and you can't currently. Let's see. Let me just double check on this one before I. Yeah, we kick it off. We do the. Yes, SageMaker works with it, but RoboMaker doesn't. And so we run lots of RoboMaker jobs to run robot simulations, so we can do fewer physical tests with robots for a given pull request, for example. We can run simulated robots and check how well your code works based on that. But today there's some Lambda glue to help handle that, and we could get rid of that if that was integrated with step functions, things like that. But in general, yeah, it's something that we use every day, and engineer on my team used to sort of automate everything as Jenkins scripts, and then when he saw step functions, he was like, oh yes, I can just switch all these things that were in Jenkins to run with step functions, and there's like one less thing I have to deal with. And now he's pretty much our step functions expert, our foremost expert. We have a bunch of people who are pretty expert in step function.
That's really cool. And I've actually done quite a few of that similar thing that you just described earlier, in terms of using step functions to use to trigger Lambda to process a large S3 file in kind of like a recursive loop. Like I said, just sometimes that's just easier than to spin up a Fargate task, because you don't have that trigger. You still have to go through Lambda to trigger your Fargate task and all of that.
Yeah, and code build is like kind of an easy out for that, because you can use a build spec file to define something to pull in your small snippet of code, but it feels like a workaround.
What advice would you give to people who are just looking to start their serverless journey today? Anything that that would really help them get started quickly and avoid common mistakes?
Well, I think the most important bit is adopting the serverless mindset, which is something you can do even before you can use serverless, the technologies that we refer to as serverless, right? It's about wanting to own less technology to deliver customer value better. And so this is sort of, an example I like to cite about this was that our administrator who handles Jira came to me, and because we have self-hosted Jira, and said, I have trouble. We've got these EC2 instances that we're running Jira on, and they're FreeBSD, and no one knows exactly how they're configured and all this stuff, and I'm afraid they're going to fall over and everything's going to start on fire. And so what we looked at was, okay, how do we set this up to have as little operational burden on that admin, so that they could go back to Jira administration, right? Operating the software on it rather than the infrastructure underneath it. So that meant, using Amazon Linux 2 and setting them up to be immutable, so that if one of them went down, you could just bring another instance up rather than having to configure them. Setting them up with RDS rather than a database inside an EC2 instance. All these things are possible, even though none of the things that are involved are very serverless themselves. It's applying the same mindset. And so even if you're really interested in, like, oh, Lambda looks really useful, but I'm stuck with all this stuff that I have to do, as long as you're thinking about how does this help me deliver value to my customers better, whether your customers are end users or another team in your organization or just other members of your own team, I think that's the very first step or the best step you can take. The technologies themselves, I think we can see people get bogged down when they haven't adopted that mindset, where they're saying, oh, I'm going to, I have lots of lambdas or I have really big lambdas because that's the code is familiar to me and I'm applying all of this custom logic in here. And that's where we start to get away from the real value of serverless, which is owning less technology.
Do you see serverless as the dominant paradigm in a few years' time, or do you think serverless and containers are going to blend together like Tim Wagner predicted a few years ago?
I mean, the way that I think about this, I don't know that serverless will be dominant, especially given the rise of Kubernetes in the last couple of years, because Kubernetes allows people, it solves a lot of the current pain points that people have with containers without asking them to rethink the paradigms that they're using. So it presents them with a familiar architecture that's server-based while solving a lot of the operational concerns and architectural concerns that people have. And so I think that's delayed serverless adoption by a couple of years because it's enabled people to get to some place where they feel comfortable and feel like things are going better, even though they're missing out on all these substantial benefits from serverless. What I hope to see is if I look at, for example, Fargate and Lambda, what I'd like to see is not Lambda adopt more container-based features. I don't really want the ability to provide a container image to Lambda. I don't want indefinitely running Lambdas. I don't want hour-long Lambdas. 15 minutes is enough. If you got to go over 15 minutes, you should be putting it in a container, in a ECS task instead. And you can't wrap it in a step functions loop, that kind of a thing. Because there's never a limit to how long you can go where everyone will agree that that limit is enough. You change it to half an hour and someone will say, I need 45 minutes. You change it to 45 minutes and someone says, I need an hour and a half. And then eventually you've got indefinitely running Lambdas that can't get cycled out. And the scaling from Lambda gets worse, so it's harder for them to make it cheaper. All of these things come up. So instead, what I'd rather see is more of Lambda's features be brought down to Fargate. So I'd like to see a Cloud Run-like model in Fargate where it's counting requests and creating new containers based on number of active requests, as well as having like Lambda's event source mappings. So everything that you can use as an event source for Lambda, you should be able to use as an event source for Fargate. And then the difference is relatively minor as to how your compute is running for a given part of your architecture, right? You've got your infrastructure graph, and for a given compute node, the rest of the architecture doesn't care whether that's Lambda or Fargate. But what I do want is that there is a gap in features between Fargate and Lambda. What I mean by gap in features is that you can't do everything you want to do in Fargate on Lambda. You need to rethink how you write code to use Lambda because if the gradient between Fargate and Lambda is too small, then people will move as far in as they're comfortable and stop. And what you really want is that there's a little bit of a hump to enter Lambda that makes you have to rethink a little bit of what you're doing in a way that then you can start to realize the benefits that go by really investing in Lambda and serverless oriented architecture. And without requiring that little bit of a rethink, I think people won't actually rethink. They'll get as far as they can without rethinking and then just stop. Does that make sense?
Yep, absolutely. At some point, you want people to get off the faster horse and get into a car, right?
Yes.
And I do think what you mentioned about Kubernetes and some of this tooling making containerized environments seems a bit better is definitely holding people back, I think, more than they probably realize, because Kubernetes is a really complex beast and people don't realize
yeah.
how much how much cost goes into running and maintaining a Kubernetes cluster. Now they look at the cost of Lambda being slightly more expensive, but then don't realize that they got a team of 10 people looking after their Kubernetes cluster.
Yep.
So with that in mind, are there any other sort of, untapped potentials and use cases that we haven't really seen people explore with serverless and with Lambda?
Yeah, I think one of the areas that I'm interested in is organizational administration. And I'm interested in this with systems manager automation documents, as an example, where if I want to run a piece of code against every account in my organization, that today is not that straightforward. If I want to deploy infrastructure to every account in my organization, I can now do that with CloudFormation stack sets. But then invoking that infrastructure, using it to do something, is, I think, the next step. And simplifying the way in which I can do that, especially in an IAM sense or in an S3 sense, so that I don't have to push the same code to every region and every account so that it can be accessed by Lambda to get deployed, kind of a thing, is something that I think is lacking. I'm really excited about the shift to AWS single sign-on because I think it moves a lot of the complexity of AWS accounts and roles mappings from being inside your identity provider to inside an AWS service. But I also don't see, today you can use it with the CLI v2, but you can't use it with Boto 3 or any of the other SDKs because they don't recognize where that token that you get from your identity provider or whatever gets stored. They had to sort of revamp some things to make it work for the CLI, and that exists in Boto Core v2. That's not brought into the SDKs yet, which means all the tools that are based around Boto or the other SDKs, like the SAM CLI, can't use SSO sign-in yet. I'd love to see that in Amplify, right? So Amplify lets you create web apps with a backend very, very simply. And you can add auth, and you can say, I want this to be a Cognito user pool or whatever you want your auth to be. If they added AWS single sign-on to that, all of a sudden you'd have teams within the enterprise that could create their own web apps that would be authenticated using the organization's single sign-on and fully protected, fully using best practices for all the things that they're building with it. And then they'd be able to create their own applications that much more easily. I think that matters a lot for even just sort of back-end teams that want to put a user interface on the front of their API. They could do that with Amplify if SSO auth was an option. AWS single sign-on, the service auth was an option.
Yeah, I've seen so many different teams that build basically their own version of the kind of bridge between some kind of a single sign-on process that kind of integrates with the tooling, with Boto, with SDK, so that the developers doesn't have to constantly copy and pasting credentials into their credentials files and setting up new ones every time the tokens expire. Something that comes from AWS and integrates with all these different tooling that already exists from AWS. Yeah, that would be really, really helpful. I think they've done a lot of work the last couple of years already around organizations and all of that, but there's still a constant pain point for a lot of customers and companies that I've worked with in the past as well.
Yep, for sure.
So I think we already covered a lot of the sort of wish list you have. Is there anything else that you want to sort of mention around your wish list items?
I think we covered, the big picture.
Yeah, I think we covered quite a lot of them already. Okay, that's great, Ben. Thank you so much for sharing so much of our insights and also potentially what the future holds for us as a serverless community. Again, take it easy and hope that things are not too bad where you are, and stay safe.
Yeah, thanks again for having me.
Okay, take care. Bye-bye. That's it for another episode of Real World Serverless. To access the show notes and the transcript, please go to realworldserverless.com. And I'll see you guys next time.